So continuing on, does the organic molecule contain heteroatoms? The answer is yes. The next question that's most relevant to ask is, does the molecule contain a carbonyl? So carbonyl is a carbon-oxygen double bond. That's a carbonyl. The answer is no. We'll address that here in a minute. But if the answer is yes, there are several different possibilities for what it could be. We'll just draw the names of them. So, a ketone, aldehyde, a carboxylic acid, ester, or an amide. There are more, but for our class, for this survey, these are the ones to be concerned about. So a ketone has a carbonyl, so carbon-oxygen double bond, with two R groups on either side of that carbon atom. Where R is any carbon containing group. For example, if you've got I'm going to use condensed structures to make this easier. Both of those are ketones. The R groups aren't the same. So that identity can change. It could be 2 carbons long, 3 carbons long, or 1,000,000 carbons long. If it's got that carbonyl in it with 2 carbons on either side, it is a ketone. An aldehyde is similar, but instead of 2 R groups on either side, it only has 1. You have a hydrogen atom instead of an R group, so a single hydrogen atom. Aldehydes are usually they are at the end of a molecule, just meaning just one end of it or the other. A carboxylic acid is an R group, a carbonyl, but instead of the R group, it has an oxygen bonded to a hydrogen. So you're substituting that R group in the ketone. Gives this its characteristic. It's that. Ester. Change the color back. Erase that a little better. Draw the carbonyl first. So similar to carboxylic acid, but instead of a hydrogen, you have an R group. And an R group, again, is any carbon-containing group. And then an amide carbonyl. What's next door to it is a nitrogen atom. That's what makes the amide. What's unique or special to the amide is what I've circled in red there. You have a carbonyl, a carbon-oxygen double bond, and then right next door is a nitrogen atom. It has to be next door. It has to be a neighbor. You have to have a carbon-nitrogen single bond in order for it to be an amide. And those are the predominant carbonyl containing, carbon-oxygen double bond containing functional groups that you'll encounter in this course.